Hello YouTube. In this video we're going to be starting a module on how to create frequency distributions. Specifically in this one we're going to be creating categorical frequency distributions. However, we're going to start with what a frequency distribution is in the first place. When we collect data, like you see a set of data here, this is called raw data because we haven't done really anything with it. When we do collect data, we tend to want to organize it so that it looks a little bit easier on the eyes than what it looks like right here, which I suppose we could draw some conclusions from this. I mean, let's go ahead and read through what I've got right here. It says, suppose a researcher wished to do a study on the number of miles that employees of a large department store travel to work each day. So maybe that's something that's important to them. They'd first have to collect the data. So they've got the data, and they'd ask, their employees, how far, from work in miles do you live? But they'll go ahead and collect it and organize it into this array. One really nice thing about collecting it and organizing it this way, I do want to point out, is this. They've organized it into like rows and columns format. So you notice you have 1, 2, 3, 4, 5 rows, 1, 2, 3, 4, 5. Looks like 10 data across. So this being 10 and this being 5. You know that you've already asked 50 people. Here's what we'd like to do. We'd like to create what we call a frequency distribution for this so that we can kind of interpret a little bit better. So let's just go ahead and start with the word frequency. Frequency. Frequency, the base word of frequency, of course, is frequent. And when you talk about how frequent something is how often it occurs. So what we're doing is we're going to organize this in such a way that we could see how often certain data occur, at least within certain what we call classes or separated numerical, neighborhoods. Okay, so you'll see frequency distribution has been actually created for this data set down here already. And the nice thing about organizing this data this way, it tends to allow us to see where the data occur the most. So like if I said, okay, again, we're the employer and we have our employees fill out the survey. What I can tell you right now is, looking at our classes or our separated numerical neighborhoods here, like 1 to 3 miles, 4 to 6, 7 to 9. I can tell you right now that most of my employees live within 9 miles of work. Okay, and the nice thing about this table is not only do we do a tally, and this is kind of like almost a graphical representation of it, but we run the frequencies over here. So frequency, when we talk about what a frequency is, it is a count of how many data occur within a certain numerical neighborhood in your data set. Okay, and so basically, and you see that we have 50 data here is what we counted above. That's what a frequency distribution is. So let's go ahead and talk about creating a categorical frequency distribution, starting with this. The definition of a frequency distribution. A frequency distribution is the organization of raw data into table form using classes and frequencies. So we're going to use these terms a lot today, class and frequency. You think about the class as being where data fit into, and then frequencies, how often they fit into those classes. Okay, so we do have two different types of frequency distributions before we make our categorical. We're not going to be doing the grouped frequency distributions here. That'll be in my next set of videos, but we're going to be doing the categorical here. But there are two types. Okay, and so categorical we're starting with here. The important thing to note here is that when you're discussing categorical frequency distributions, it's not always the case, but these are distributions when we are talking about qualitative data types. So remember, qualitative, the base word there being quality. These are data types like color, or political preference, or blood typing, things such as that, because they are non-numerical values, okay? Or at least they constitute their own category, each one of these things. So what I've done here is I've kind of given us a set of raw data, and what these are blood types of hypothetically of 25 Army inductees when they were given a blood test. So we see their blood types here, and you notice that we are organizing this raw data again into kind of a row column array. So we see we have 1, 2, 3, 4, 5 columns, and then we have 1, 2, 3, 4, 5 rows. It makes it easy to count that we have 25 total data. But what we want to do is create a categorical frequency distribution for the data. Okay, so the first thing you always do when you create a distribution is you start with your classes. You need to determine the classes first. When it comes to qualitative data, it's kind of an easy thing to determine what your classes are, because each different type of thing, like type A or type B or type AB or type O, these constitute their own classes. So the first thing we do is we set up this table here, you can see, where we have our first column is our class. And so we have our type A, type B, type O, type AB. But then you also notice other columns here. And so I want to point something out here. When we work with Microsoft Excel, it is often convenient to refer to as a column with a letter. So column A, column B, column C, column D. So that when we do formulas, we would say something like, take cell B2 times cell C2 and that would be like take you know, the tally times the frequency, which I would never do. I'm just saying that's what you would do in Excel. So we letter these, but we also title them. So class, tally, frequency, and percent. And so tally is exactly what it says it's going to do. It's going to tally up like how many types A there are. So we have a type A here, you know, I put a tally. We can actually go through and just count how many there are total if there are not many. So we have another type A, type A, type A. We could circle these, type A. So I have 1, 2, 3, 4 more types A, and we can cross those off. So 1, 2, 3, 4. So we have 5 total in this class. We'll talk about the percentage last. So type B. Okay, so let's go do our type B. I'll switch over to blue here. We have a B, B, blue for B, B. Go through, circle all my B's here. B, B. B. So total B's, we have 1, 2, 3, 4, 5, 6, 7 total B's. So, you know, if I don't think I'm going to, you know, biff things up here, I can go ahead and count them up front. You know, if I have a lot of data, I'll probably abstain from doing so. So I'm going to cross those off now. So all the B's are gone. Okay, so next we're going for type O. You know, let's run through, do our O's. We say 1 O, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 types O. We have 1, 2, 3, 4, 5, 1, 2, 3, 4, 9 type O. And then type AB looks pretty rare here. We have 1, 2, 3, 4, 1, 2, 3, 4 tallies. And so frequency, again, is the numerical count of the tallies for each class, okay? So when we talk about percent, you know, I want to bring something up here with percentage. When you talk about the percent for each class, there's a way to determine this. We're trying to figure out, okay, so what percent of the overall number of people we surveyed were like type A here? You know, we had 5. But 5 out of how many? So one thing I want to mention here is this. When you make a categorical or group frequency distribution, when you go through and you count up all of your frequency, we're always going to call this number N. This N, let's get used to this now, it stands for number, okay? Number of data. How many data we had. So we had 25 data, but if we go through and add these up really quickly, you can see that we get this 5 plus 7 is 12, 12 plus 9 is 21, 21 plus 4 is 25. We have 25 total data. What we're going to do is we're going to take the frequency for each class and divide it by the total number of people. So we say the percentage, the percent of overall is always equal to this. Frequency is a lowercase f. We say frequency divided by number, sorry for the handwriting, of data. So we could write this also as F over N, okay? So when we talk about the percent in the first class up here, we say, oh, you know, we had 5 out of 25. And I know I'm writing this kind of sideways here, but 5 out of 25, and when we pull out a calculator, not that we need to do this for 1/5, it's 0.2. But just to show you say 5 divided by 25. So we get 0.2, okay? So what this means is the percentage for this category is 20% of the overall. So 20% of the people we surveyed were type A. Let's talk about type B. It's got to be more than 20%. So getting our calculator out here, we've got, okay, 7, which is our frequency, divided by 25, which is the total data. So we have 28%. So I'll switch colors, I'll alternate here so we know which one goes with which. 9 divided by 25 here. So the frequency 9 divided by the total amount 25. So 9/25. We have 9 divided by 25. So this was 36% of the overall. And I did say I was going to switch colors here. So, whoops. Switch colors, 36% of the overall. Go to types O. And then 4 divided by 25. It's got to be less than 20% because it was less than that first class. We say 4 divided by 25. So 16%. So another thing to mention here is if you sum all these, you should get 100% of your total amount. You should check that there. But, you know, what conclusions can we draw from this group frequency distribution? Well, you know, obviously it is that type O is the most prevalent. You know, 36 out of every 100 people are type O, it seems, based upon this sample. And so we say based upon our sample, we could draw, you know, a prediction about what would be true about the population. So, but type O is most prevalent. But yeah, this is how you construct a categorical frequency distribution. You just throw your classes in, do a tally frequency, and then find your percentages using this little ditty over here. So, cheers.